Yeah, this is just an old, difficult, old bonus question here. I don't know, you can plug 0 in and see what you get. That is kind of what you're supposed to do with your limits. But you do get a 0 down here. What's e to the 0?
1.
E to the 0 is 1, but you get a 0 here, so you got a 0 in your denominator. And your numerator is e to the, that's a 1, that's a 1. The cosine of 0 is 1. So it's 33.6 minus 33.6, I think, because everything's 1. So that's a 0. So it's 0 over 0. I would factor out a 33.6 e to the 2x. What are you left with if you factor out 33.6 e to the 2x? 1 minus cosine to the 4th. Oh, wait a minute. And there's an x squared here, right? Right. Sorry about that. I lost him.
Right.
So that was factoring. You guys, you can do that. That didn't help much yet. You know what I'd like to do? Can you divide these numbers? What is 33.6 divided by 0.12? 280. Really?
Yeah.
She divided that and got 280. Hey, I'm going to take this e to the negative x. I'm going to move it up. It'll become an e to the positive x. I can join them with this, and that's e to the 3x. You okay with that? So I divided the numbers, and I joined my e's, and now I think I want to factor this. This is like the difference of two squares. 1 minus cos squared 3x, 1 plus cos squared 3x. All over x squared. How you guys doing? You guys okay? This was like the difference of two squares, so I factored it. Man, I hate to give this away. I'm giving it away. Giving away the farm. Do you have any ideas? If you have an idea, then it's not giving it away. Yes?
Would you use one of the trig identities?
Yes. Which one?
For 1 plus cosine squared dx, or 1 minus plus. And you replace it with sine squared.
Yeah.
Right.
1 minus.
She's on to something. You guys, listen, you know the most famous trig identity there is cos squared plus sine squared equals 1, right? Did you know that?
Yeah.
That's the most famous trig identity there is. And then it comes in a couple other forms. Like if you move the cos squared over, sine squared is 1 minus cos squared, or vice versa. Cos squared is 1 minus sine squared. I mean, those are a couple other versions of this which are useful. So this is one identity in it. It's useful in a few forms. But I want to use that concept right there. That 1 minus cos squared could be turned into a sine squared.
Yeah.
Sine squared 3x. Yeah, it'd be a sine squared 3x. Jesus. Who made up this problem? 280. So I'm changing this. So what am I doing? I'm changing this to sine squared 3x.
Right.
Now, as I do it, I'm going to go ahead and call it the sine of 3x times the sine of 3x. I mean, that's sine squared, isn't it?
Yeah.
But I'm just spreading it. I want to see it. I want to see it like that. What's this? 1 plus cosine squared 3x. And it's all over this x times this x. Or this x squared.
Yeah.
You guys got any ideas now? Well, here's this again, and this was on your quiz Friday, and people didn't do too great with it, but this is that theorem again. And when x goes to 0, this is a 1, but hold on. It's only a 1 when the argument of the function matches the argument down here. I mean, when it's an x over an x, it's a 1. If it's a 3x, then this needs to be a 3x.
Right.
By the way, what you can't do is take this 3 out here. That's illegal. But it feels like you can, because watch what I'm going to do. I'm saying he needs a 3. So I can multiply by a 3. As long as I multiply the numerator by a 3.
Yeah.
Because what have I just done? I multiplied by the number 1. But now, this fits the form of my theorem, and this can go to 1. What about this one?
Do the same thing.
Same thing. I need to multiply by another 3. So I'll need to multiply by another 3.
Okay.
And then this will be a 1. When I do the limit, those go to 1. What's this? E to the 0?
1.
Dude, we're done. We're doing the limit.
Yeah.
This is 280. E to the 0 is a 1. This is 3 times 3, which is a 9. And when you plug in a 0 there, the cosine of 0 is 1 plus 1. That's a 2. We're done. There's the answer.
Oh, wow.
What the hell's that answer? You may not have ever found this on your graphing calculator. You could have found it on your graphing calculator. It's 5,040.
Ah, that's so awesome.
That's a pretty good problem. You know, on your quiz last week, on last week's quiz, you had this problem. You guys okay? You had this problem on your quiz last week.
Right.
And the answer is 3 halves. And some of you were writing 3 halves and your work was terrible. I don't know I'm not sure how picky I got, but I could get picky. I mean, the right answers are not what this class is always about. Work, you know that, right? Work and explaining. Just because you get a right answer doesn't mean you get full credit. The process has got to be good. So I don't know. I can get picky about stuff sometimes, but I should be. Anyway, if you first try this problem, you get 0 over 0. And if you want to try to use that theorem, you can use that theorem, but this 3x has got to match this. I mean, and this is a 2x, and it needs to be a 3x. And the way you make that happen is this. You sort of, I mean, you kind of want, that 2 is times that x. So they're still times each other, okay? The 2 is still times the x. But now I need that to be a 3x. I need this to be a 3x. So can I multiply a 3 in there?
Right, and the top.
As long as I
Top.
multiply by a 3 up there.
Yep.
Now you forced it. Now you're hitting the theorem. This is now a 1. When you take the limit as x goes to 0, he becomes a 1, and the answer is
3 halves.
3 halves. But that's the proper way to do it. The funny thing is, in a way, I don't like this question because you can do it improperly and still get the right answer. And that always bugs me, but I might have been, I don't know.
So you took.
I need this to match this.
Right.
So, and you can't pull the 3 out. See, some people make it match by doing this. Oh, I'll pull that 3 out.
Yeah, it's wrong.
And then that's my 1, and the answer's 3 halves. See, that's not the right way to do it. I'm sorry. And some of you did that, and I can't remember if I took off a point or not. I might have forgiven you, even though I'm mad at you.
Yeah, so we lose.
But this problem was only worth a few points. But anyway, you don't That's bad algebra, bad trig. You can't take this out. That's bad algebra, bad trig. You don't do that. So you can't take him out. So you have to add something to the bottom. You got to make this a 3x. Multiply by 3, multiply by 3. That makes it a 3x. Right. All right. You might have other questions on this quiz. Listen, I'm kind of out of time. I guess I'm gonna quit. But one thing I'm gonna do is hand you back all that stuff.